Right, so we'll talk about edge computing for enterprises. So if you go to the next slide, okay, right. So when we talk about edge, it can really be one of three different types of edges. It can be an edge device, or an edge server, or a network edge. So it could be the enterprise. It could be on an enterprise premise where edge services can be executed on devices and edge servers, but it can also be on the network edge, a telco premise where edge computing can be delivered from central office or aggregation centers. And these are really exciting times for these telco and communication service providers, with the emergence of 5G and virtualized network functions. They really are using edge as a way to monetize their existing infrastructure at their central office. But that's about the edge network. Today, though, we'll be focusing more on the edge server and the edge devices that typically run, inside an enterprise, and they can be single tenant. Though they're usually single tenant, but there are some instances where it can be multi-tenant. And in this enterprise edge, you would be running a particular, inside a campus. So it could be a factory or a hospital, a stadium, or a shipping port. And the edge enterprise can consist of both edge servers and edge devices. An edge server or an edge cluster is a server that is installed outside of the traditional data center or public cloud, often at a business's remote office or a branch office, or it could be a distribution center or a warehouse. And this server is typically owned by the business. And an edge device is, a fixed function equipment, such as a smart camera or an elevator, a conveyor belt or a car or a robotic arm. And these equipments typically have compute and memory storage that is accessible for clients to use directly to run their own workload on the edge device itself. Versus running the workload back at a data center or a public cloud. And also, to be clear, we do not consider IoT services, IoT sensors as edge devices, as IoT sensors collect and transmit data to another location. But for an edge node or an edge device, they have onboard compute and memory. And I think Glen and John will be talking a little more about some of these differences a little later. The first, let's go on to what are the key tenets of IBM edge computing. So when we look at the four key pillars of an edge computing platform, the first pillar will be around that it should be an open and consistent platform. So by open, I mean it should be open standards or open source based. Our platform, IBM Edge Application Manager, or IEAM, is based on Kubernetes, actually OpenShift to be specific, which is open source, and it provides that consistent environment. So you could run OpenShift in a public cloud or a private cloud or on-prem in an enterprise. So that's the first pillar, the platform. The second pillar is the distribution and management of workloads. So over the next few years, as enterprises adopt these edge topologies, they'll have to manage hundreds of servers or thousands of these edge devices in their deployment. So existing management approaches are not built for this type of environment. So when you start deploying, you can't get the same server across each of these different locations. And you'll notice that there's a lot of variability in the deployment environment. When an enterprise adds new locations, which they will over time, the variability increases. And if you have hardware outage, you'll notice that the new servers, they don't look like the old ones. Now imagine if you're an administrator who must deploy workloads into these environments. Sure, you can write a script, but then you'll need to know what is the topology that you're deploying into, and how do you know which server types or device types are deployed where, and how much storage or network, compute, memory, which version of OpenShift or Kubernetes, and what are the other softwares that are running on that edge point. So it's really difficult to do all of that, especially when new devices and services are being added continuously. And to address this challenge of edge management, you need a new approach, an autonomous management approach. So that means the management actions such as the negotiation and agreement that Glen briefly spoke about are all autonomously carried out between IBM Edge Application Manager and each edge endpoint, which is running a lightweight agent on it. And these management actions are carried out autonomously based on administrator intent, but without the actual intervention of the admin. So that makes it really autonomous. The third pillar is about security. It is important to prevent things like man-in-the-middle attack, and security of these edge devices are critical. So out-of-the-box encryption, tamper-proofing, and attack prevention is really required to reduce the risk. And fourth is about what are the actual workloads that will receive the most benefit of being deployed out at the edge. These are some application services in the area such as analytics and AI that are key workloads that not only benefit from the low latency of being deployed out at the edge, thus improving performance, but also benefit from a data security and data privacy ability by keeping data in a campus environment. So with that, I'll just briefly talk about the IBM Edge Application Manager components. And my colleague Glen is a real expert here, so Glen, feel free to step in anytime. But at a very high level, we have the Edge Management Hub, which is the centralized single pane of glass for management actions, often deployed in a public or private cloud. We have the Edge Agent, which runs on Edge nodes and is used to express the capabilities and properties of Edge node. And it's part of that whole autonomous management platform. And the administrator intent is captured in YAML files that express the needs and constraints of a particular workload and is stored in that exchange. The exchange itself runs on the management hub and is encrypted peer-to-peer message mailbox system, one mailbox per edge agent, and each edge agent checks continuously to verify if there are new or updated workloads that need to be deployed. And the agreement bot or the ag bot runs on the management hub and is used to form agreements between the edge agent and messages in the exchange. So this workload placement occurs on individual edge nodes as a result of this agreement that is negotiated between the edge agent and the ag bot based on the conditions that are expressed on the administrator and the capabilities and properties of the edge node. And continuous verification of these negotiated agreements in the presence of changing conditions are carried out by the ag bot and node agent. I don't know if you wanted to add anything there, Glen. Oh, sorry, Glen, you might be on mute.
Glen's on mute. Let's see if we can bring him in.
Sorry, I just wanted to clarify that the files that we use to describe the individual nodes and the services and so on, we selected JSON as our encoding, not YAML.
Okay.
But everything else was perfect.
Yeah, well
Good job.
Thanks.
All right, so I think let's do it. You're going to talk for one more slide. Let's talk about the data set and your hard hat detection model. Is that what we're going to get to next?
Yeah, I was just going to go into one more slide, just saying what are the different edge deployment options. So, depending on the hardware that you have and the particular use case, you can either deploy these workloads directly on an edge server, or you could deploy it directly on an edge device like a smart camera. And actually today in our use case, we're doing a combination of both, where we have a simple lightweight model that's running on the smart camera or the edge device. And we have a model that we have built using IBM Maximo Visual Inspection. And this is specifically trained to identify an object, right? In this case, it's going to be a hard hat. And we've deployed that onto the edge server. So yeah, so I just wanted to explain, this is the kind of architecture that we have here, where we have the model creation environment, which is separate. It can be running in a central or a hybrid cloud environment. And that's where you build these models, because some of these processes require a lot of compute. And once you've built that, you containerize it, and then you have it on IBM Edge Application Manager, the management hub. And from there, you can deploy these different models, depending on the model, either to an edge device or to an edge server. In our use case, though, we'll be just doing it on one edge device and one edge server. But really, to take the advantage of some of these autonomous management, it can be done on multiple edge devices and edge servers with just the same single deployment policy. So yeah, with that, I think we can jump straight to the video, and I can walk you through our implementation of this. Great, yeah, thanks. So yeah, let me walk you through actually a story, and you'll see how, oh, I think we just missed that. Let me go back 1 second. Yeah, and in this story, I'm really talking about a particular persona called Jennifer Suarez. And you know, this is back in January 2020. She's all happy. She's the VP of operations of a large manufacturing enterprise, and she's responsible for managing plant level costs and controls, as well as implementing corporate policies and procedures and ensuring that there's consistent compliance. But in January 2020, she was a little worried, as there was you know, a spike of untoward incidents regarding employee safety at 3 factories, leading to large fines. And her challenge is to ensure worker safety so as to not incur large fees, as well as keep you know, the capital expenses low at these manufacturing plants. So she takes the help of IBM Edge Application Manager and deploys a solution. So let's look at what the solution is. So you'll notice here that we have a worker that is about to enter this particular area of the factory, and it's called the danger zone. And as soon as he's about to enter that, a deep learning model that's running on that smart camera right on top is able to identify the person, and it starts streaming video to the edge server. And on the edge server, we have you know, a hard hat detection model, which detects that this particular worker is entering this danger zone without wearing a hard hat. And you'll see that an alert was generated. But next time the same worker walks into this danger zone wearing the hard hat, no alert was generated. So we'll show you how we actually implemented that. And what you're seeing now is the safety dashboard that's typically running at this edge server. And you can see there's not much happening on this dashboard because this is still scenario 1. There is no worker in this danger zone. So there's no video stream that's coming through to the edge server. But when we jump to scenario 2, you'll see that as I appear in front of the danger zone, the smart camera that has a model running on the smart camera detects a human, and then start streaming video to the edge cluster, which can do this further analysis. And since I was not wearing a hard hat, it detected that, and you can see that an alert popped up here on the screen. And then you'll see my colleague, he's the smarter one. He knows that he needs to be safe, and he wears the hard hat before entering the danger zone. And you can see here, this time there is no alert generated. So that's how we went about implementing this use case. And I can take you now under the covers and show you, what exactly happened and what were the different components that we had to deploy to get this use case in action. So as you can see, initially, there's no model deployed. I'm not detected as a person, and nor is it able to detect my phone as an object. And then we'll jump into IBM Edge Application Manager's platform. This is the graphical user interface. And you can see here there are 4 edge nodes that are registered. 3 of them are edge devices, and 1 is an edge cluster. And let's look at these edge node properties. And you can see there are 3 of these edge devices. I'll click on one of them, and this is actually a MacBook Pro that's acting as an edge device. And it's got a property here called memory equal 16, and another property called camera equal to yes. Just remember these 2 as they play a critical role soon. Next, we'll go down and see the services that are running on this device, and you can see at the moment no services are running on this particular device. And I'll show you what a service is. So if we go to the services that are currently published on the Management Hub, we'll see there are a few services here. There's one for object detection. There's one for specific things, and these are all the services that are available that can be deployed on these edge devices and clusters. And next, we'll go into policies. You can see there are about 3 policies that are already here. But what we'll do now is go ahead and create a new deployment policy. And this deployment policy, we'll just call it policy object detection. I'll provide a brief description. And importantly, we'll associate the object detection service. And that's the service that I just showed you a moment ago in the services tab. And we'll associate this service to this deployment policy. Next, we'll add constraints. So we specify that this particular object detection service must be deployed onto edge nodes that have memory equal to 16, as well as camera equal to yes. So if you remember from before when I showed the edge nodes, these were the 2 node properties that were mentioned for one of those devices. So I'm mentioning this as the constraints. And then, so I'm just reviewing it one final time before I actually publish this policy. And you can see now it's published. This is the policy. It's got this service associated with it, the object detection service. And it's got these 2 constraints, memory equal to 16 and camera equal to yes. So as soon as this policy is now published, on the back end, what's happening is the negotiation between the IBM Edge Application Management Hub and all the registered edge nodes. And you'll see here, this particular edge device, it's already running that service now, because in the back end, the negotiation has occurred and the agreement has been reached upon. Because these constraints have been met for this particular edge device, which is memory equal to 16 and camera equal to yes. So that's why this particular workload was deployed on this. And just as an example, I'm going to show you another edge device here. It's very similar, except that the memory here is only 8. As opposed to the minimum requirement of 16. So this particular edge node doesn't have any services running on this yet. Okay, so back to the demo, right? So now we've shown you how to deploy these workloads and AI workloads onto the edge nodes. And you'll see now that this object detection model is deployed onto the edge node. It's able to detect me as a person. One thing to note here, it's still not detecting the hard hat because this is the model that's running on the smart camera, the edge device. And it's a small device, right? So it can't really run specific models that are pretty heavy. So it's a simple model that can detect a person. And since that model detects a person, it then starts streaming video over to the edge server, and the edge server then gets that video stream, and that's where we have the hard hat detection model. So you can see here, I'm still wearing the hard hat, so there's no alert generated, but the moment I take off the hard hat, it's able to detect it, and then it throws an alert. Again, this is just one example, and if I want to continue back my story, going back to Jennifer, a couple of months after January 2020, as you all know, we were all hit by the pandemic. So suddenly, hard hat is still important, but she needed to now start deploying models that can detect face mask, right? So going through the same process of creating a new policy and updating the model, instead of detecting the hard hat, we had to change the model such that it could detect a face mask. So if I'll just go through this a little quickly, it's the same scenario, the same part of deploying a model, but this time, we're going to start detecting the face mask. So you can see here, as soon as I remove the face mask, it's able to detect that I'm not wearing a face mask, and now it generates an alert for the face mask. So that's the use case and solution that we had with that, and that we wanted to share with you today.